Good afternoon, everybody. I'm Luca from Pi4AI, the upcoming Python and AI conference that will take place in Pavia on the 16th of March at the headquarters of C-Vision and ArgoVision. Today I'm with Cesare Bassu, a data engineering manager at Facile.it. Cesare, it's a pleasure to welcome you. So let's get started. Today I want to make you all really eager and really interested in this upcoming talk. So without further ado, Cesare, what will we be talking about at your conference? What will you be presenting?
I will be presenting how we handle predictive models through the MLOps perspective. In this speech, we will see how to handle predictive models from the beginning until the retraining phase using different technologies like the CI, like Terraform and Vertex AI that help us to handle all the phases.
That's very interesting. And so you do a lot of MLOps, and that's a kind of side of data science that became mainstream and has been maturing ever since like 5 years or so. For how long have you been a data engineering manager?
In Facile, I am a data engineering manager since 1.5 years. Yeah.
Okay.
Before that, I used to work on these topics in another company. And with different technology.
So basically, you've been like doing MLOps for at least 3 years or even more.
Yeah, 3 years is a good way. Yeah.
That's a lot of time, and that's a lot of precious experience that it's not had around. And my first question is, MLOps is not something you study at university. So how did you learn it in the first place?
Let's say that it is a need. When you have a little team and you have to handle a lot of predictive models, it becomes a need for the team. Otherwise, you don't have otherwise, you cannot handle. You cannot scale.
Okay, yeah, I can imagine that Facile has to scale for a lot of products and a lot of models, and I cannot even fathom how many models you have in production. Can you give us like a hint or something, an order of magnitude, to say we have more than 100 or something?
No, it's less than 100, but it's still a lot.
Wow. Okay. And still digging into this topic, how has MLOps changed in these 3 years that you've been working with?
It changed a lot. A lot of technologies are now handling the different parts. We use, for instance, Vertex AI, which is the one in the Google Cloud platform. We like a lot, and it's very it's growing a lot, especially these last 2 years has grown a lot. How has it changed? For example, at the main part is the pipeline. The concept of pipeline in a machine learning process is something that everybody needed, but there weren't a single technology that could do it very, very well. But this is the first part. On top of that, a lot of bricks have been added into the pipelines. So this is the trend. We have, for example, the pipeline, and then a lot of steps that can be done on top of that, and this is how it is growing.
And so, what kind of steps are you referring to? Is it perhaps like model monitoring?
A step could be model train. Another step could be a model a dataset split. Another one could be a hyperparameter tuning.
Okay, so there's a lot of stuff that has been formalized, and you say that the engineering is being figured out more. It's a bit more standardized.
Yeah. It has been standardized because what happened in these years is that machine learning engineers discovered that all the predictive models has the same shape, so they can be standardized and formalized. So this is what led to create a standard.
Okay, that's very interesting. And how do you handle retraining with the models that you have in production? Do you retrain at a certain frequency, or whenever you see there is a shift in the covariates below?
It can be done in both cases, in both ways. It really depends on the specific field. For example, there can be a model where you have a response for example, in 1 hour, in 2 hours, in 1 day, and in these cases, you can find you can use for example, the drift as a main way to retrain the model, or otherwise in the model where you don't know if you don't know the correct label until some time passes, you have to do it programmatically. For example, every month, every 2 weeks, or whenever you prefer.
And does the technology that you use in your stack allow you to schedule the retrain, or you have to code it for yourself?
No. You can directly schedule it. Yeah.
Oh, okay, that's a really lot of it takes a lot away from the overhead and the engineering part. Am I wrong?
Sorry?
So you don't. So is there and as a data engineering manager or machine learning engineer, it kind of feels like you're starting to just say code less, or you have to build less things from scratch.
It's rare that we create something from scratch so far, because we have, for example, something that we call a model skeleton that creates a good part of the code, and what the data science team has to do is to tailor this part of model. To tailor the code part for the specific model, but in general, we never start from scratch.
And so do you think that a data scientist is also a data engineer, or vice versa, or they should still be seen as two separate roles?
I suppose they should be seen as separate roles, but there is a must that someone in the teams has to understand both of the fields.
Okay. And so as a manager, how many people are you working with, and how many are data scientists, and how many are data engineers, and how many are machine learning engineers?
Yeah, the two teams are, let's say, little. The sum of that is less than 10 people.
Wow, okay, that's really agile. And how do you manage working with them? What kind of management style you adopt, and how do you make them talk to each other and understand and make sure that they understand the technical challenges of each process of their own part of the job?
Okay, we have, let's say, two different flows. One flow is dedicated to the models that they are developing. So in this case, they, let's say, contact us, or we plan some task together to put the models in production. Another one is a flow where we talked on how to improve our MLOps stack, for example, or repositories that we have, which handle all the predictive models that we have.
Thank you. That's very interesting. And speaking of your work experience, what are some common challenges and misconceptions related to MLOps?
Okay. Let's say the first part of MLOps is to create some standards. This is the most heavy part, but it has to be done only once at the beginning of the process. Once you have it, you only have to reiterate. So to create a little adjustment, you don't have to every time to spend a lot of time to put a model into production. So if the first model that you put into production can take a lot of time, all the other models really can be done at scale.
And That's a very interesting question. So, how do you know? So, I think that the tough part of this is going from 0 to 1, right? Because then from 1 to 10 or from 1 to 80, it's relatively easy. But how do I know that I am at 1, or maybe I'm just striving to get to maybe 10 or something? I mean, how do I know if I am wasting time setting this up? How can I still be fast in developing, and when do I know that it's good enough and I just need to develop something or deploy something and then I can iterate on it?
You can know it looking at your task. For example, if you spend most of your time handling models which are already into production, you are not at 100. You have to improve. Once models are independent and you don't have to look at them every time, every week, every month, for example, you are at a very good point.
Okay. And so if I am starting from scratch, like as a company, suppose I already have the data, okay, and I know there is a problem, and I know that the only way to solve it is using AI. So this is like a very advanced setup, right? Because most models could be, the most problems could either be solved just with a fancy SQL query, right? So
Yeah,
AI is never, it's not always needed. Am I wrong?
you're right. Totally.
Okay, good. So suppose that there's, for this one task, I need a machine learning model, and I have like a Jupyter notebook that contains the model, and the metrics are fine. So the data scientist says, "This is the model. Deploy it." Where do I start from, or where would you start from?
It depends. If you already have put a model into production, you can try to emulate it using MLOps techniques. Otherwise, you have to start from scratch. Once you start from scratch, you have to define all the steps that you have to do into your model creation phase. Once you have split it and put the code in a right way, test it, and put it to a specific function, you can use the MLOps techniques to put it into production. But as I said before, the biggest work is the only for the first model. So if it is a need, and the company or in general who want to bring the model into production really has this need, then has to invest some time of the both teams, data science and data engineering.
So suppose, like a young data scientist. Oh, okay. No, I remember the question now. Okay. So you said that you should write the code properly and test it. So, as a data engineering manager or as a machine learning engineer, how can you tell us something more about the code and the coding standards and the coding guidelines? How much are they? How important are they as a part of your daily job?
Yeah. This is always a this is always a problem to define what is good and what is not. Always the testing phase allows us to define that the code could be of like a very quality code, but sometimes happens that the model has to be. Sorry, we have to do again this question because
it's okay. Okay. Let me just rephrase that because I was super. It was super weird. So, let me just answer the question again because I made it just too broad. You mentioned that you test the code. What kind of tests do you do, and how do you test a machine learning model?
Okay, we have two different fields here. Let's say the software engineering and the data science fields that has to coexist in the same phase. For example, we split, let's say, these tests. Let's say so. The data must be okay, must be clean, must be controlled, must be splitted well, and so on. And you can do it using I know some technologies. instead for the software engineering part, we use normal tests that can be done in Python, but also in all other languages. When both tests are okay, the model goes into production. Let's say the data science test of a good quality of a model has to be done from the data science team. Instead, the quality of the code quality has to be done from the data engineering team.
Okay, thank you. And going on this track, suppose that a young data scientist or a graduate student comes to you